I'll speak first for a few minutes about some of the historical and archaeological context about Viking winter camps, and then Matthew will come up and speak to the database and statistical analysis of this topic. There are multiple written records of invading Scandinavians selecting a winter campsite in hostile territory. Annals in England, France, and Ireland record these events. Archaeological discoveries in the last 35 years have given an insight into the material nature of these winter camps. Three notable locations are Repton and Torksey in England and Dublin in Ireland. This survey attempts to compare elements of these three sites by using spatial database analysis with the goal of testing for a model winter camp site. We are interpreting the landscape as material. It's a feature to be analyzed and used, just as individual objects can be used to interpret decision-making and cultural behaviors. Were the invaders looking for certain river conditions? Did they search for certain topographical features or select resources in the local countryside? Was it important to have access to an established population or a market center? The end goal of this analysis is to create a model of this winter campsite. This model can then be used concurrently with written records and continue the search for other potential sites, or help confirm other debatable sites. By using spatial databases, we can prioritize specific weighted variables and relate them statistically, thus applying some familiar technologies, such as GIS, in new and exciting ways. We hope that introducing the use of spatial database analysis into archaeological methodology will expand the abilities of researchers and support future projects. For this presentation, we'll focus on the results of a descriptive analysis of the three main sites. We will introduce the sites and discuss the tangible elements of each, then describe the use of the spatial database as a method of increasing the sample size for Viking winter camps. Finally, we will use this increased sample size to statistically interpolate potential sites for future evaluation. First, let me discuss the function and development of a winter campsite, then I'll introduce the three primary sites under the microscope today. When discussing the adventures of Scandinavian peoples in the 8th, 9th, and 10th centuries, commonly referred to as the Viking Age, there is some confusion as to why it all began in the first place. Some scholars stick to ships and the development of new sailing technology as an enabling factor. Others, dwindling in number now, still believe that the rising population of Scandinavia overwhelmed available resources and new land was desperately needed. More recently, evidence from the realms of archaeology, economics, psychology, microbiology, and informatics, to name a few, have been intermingled to support new debate about the Viking Age and cultural mixing which occurred. Many scholars now support the idea that multiple factors were at play when large groups of Scandinavian raiders, traders, and sailors descended on Western Europe's coastal communities in the 8th century. In the earlier half of the Viking Age, invaders would perform hit-and-run style attacks, but quickly realized that if they spent the winter season at a base camp, they could raid farther inland and have a more profitable excursion overall. While these sites were temporary, there were still major centers of activity including metalworking, trade, and manufacture. Howard B. Clark views these sites as a reflection of Norwegian and Danish cultural norms in the period, pointing out that, in quote, Norwegian raiders, traders, and settlers came from and contributed to an essentially non-urban culture, end quote. This paper identifies some of these sites and argues that there were certain elements which made a campsite more favorable than others. While the idea of a booming population, forcing out rambunctious and hungry young men, is now delegated to being a minor factor in the start of the Viking Age, it should still receive attention when discussing certain areas of Scandinavia, such as southern Norway. Most areas of Norway were able to easily absorb and support a population increase, except for certain areas in the south, which had historically hosted the highest population concentrations and the best agricultural districts. Knut Health suggests that the majority of those who ventured out into Europe were from these southern communities, enticed by the arable lands, available resources, and most importantly, the rich Christian worship centers of coastal Europe. Very enticing indeed. In order to access these tempting resources, organized forces were led by local political leaders or petty kings. Bjorn Murr's overview of court sites, large living spaces with smaller spaces for a local leader to gather his men, shows that a typical fighting force was used to living in temporary conditions under the control of a central figure. Recent analysis of these sites by Staugaard and Grimm in 2005 shows clear evidence of a repeated pattern at multiple locations. Many of these court sites were along coastal trade routes at the mouth of large fjords with arable land, making a logical and effective place to collect men's supplies and tithes. This leads naturally to a conclusion that these men would easily adapt to temporary living conditions in a winter camp situation. Murr argues that the petty kings of southern Norway were actively involved in trade networks of northern Europe. After 700 AD, Emporia were not just harbors and trade centers, but also manufacturing centers. This relatively peaceful period exposed Scandinavians to other cultures, landscapes, and resources. Mera does not believe that it was pressure from overpopulation or lack of resources which led to raiding, but an increase in political power and political tensions. This hostile raiding, which began around 790, may be seen as a response to this increase. More recent archaeology in Estonia in 2008, in Saaremaa, gives more weight to the proposition that raiding and Scandinavian expansion was fueled by a combination of political, economic, and religious tensions, plus the technological ability to travel more extensively and more efficiently by sea. This new discovery and other new research projects are actively proving the need for an interdisciplinary approach to the study of this period. Let me now focus on the 3 sites in question today. First, let me discuss the well-documented site at Repton, England. Repton is located on a sandstone bluff adjacent to the River Trent in an area in which natural springs are prevalent. The river has changed its course a distance of approximately 1 kilometer at some point in the past, but it seems as if the body of water, now known as the Old Trent Water, used to be the main riverbed and was navigable by ship. Evidence of prehistoric and Roman activity is present in the surrounding area, but a settlement is recorded in 755 and 874 in the Anglo-Saxon Chronicle. Multiple 7th century documents record the presence of a monastery, and several Mercian kings are recorded to be buried there. The area around the church, marked here with the blue spot, was the subject of an extensive excavation project in the 1970s and 1980s. During the excavation in 1976 through 1979, a V-shaped ditch was found southeast of the church and chancel, adjacent to the former riverbank. This ditch continued up to the church, then resumed to continue northwest of the building. The line of the ditch was traced using resistivity survey and magnetometry. Further excavation showed evidence for a series of 4 ditches. These ditches, which were defensive in nature, enclosed approximately 3.5 acres. Excavations in and around the line of the ditch provide evidence which correspond to the chronicle date of 873 to 874. Especially important was the discovery of multiple burials with datable grave goods and the mass burial pit discovered there. This is a site map of, you can see the ditches outlined there, and then the mass burials marked here, and you can see the church with some of the modern buildings overlaid on the site, with the current coastline of the Old Trent Water, which is now relegated to being mostly a pond, and the estimated line of the former riverbank there. The excavation team also uncovered a sunken 2-cell stone building, likely from the late 7th or 8th century. This was cut to ground level at some point to act as the base of a burial mound. The mound was first excavated in 1686, and reports include details of a stone coffin. Between 1980 through 1986, the mound was re-excavated, and a mass burial of at least 249 individuals were discovered, stacked adjacent to the mound. The stone coffin discovered in 1686 was not present, but many other objects, including an iron axe, a fragment of a sword, seaxes, knives, a chisel, iron fragments, and precious metal accessories with gold decoration were discovered. In addition, 5 silver coins helped to date the burial to no earlier than 573 AD. This mass burial deposit was 80% male, ages 15 to 45, consisting of a robust, tall, non-local population. The height, bone structure, and robust nature are comparable to samples of similar date in Scandinavia. The remaining 20% is female and show more similarities to the local Anglo-Saxon population. The main burial and the now missing coffin are thought to be for an individual of high status, and the associated mass burial consists of those who died with the Great Army in England in this period, and may include bodies gathered from other sites. The mass burial and possibly the main burial were likely deposited in 873-874 during the Viking encampment. Let me compare this thoroughly explored site with a relatively new research project at Torksey, England, which is in the beginning stages of identifying and uncovering a winter camp site. Here we have Torksey and Repton marked together on the map. Torksey is northeast of Repton, as displayed here. Torksey is labeled as the location of a winter camp in the Anglo-Saxon Chronicle entry for 872, 1 year earlier than Repton. The exact location of this camp has yet to be positively identified. However, recent research is getting closer to a positive identification. Torksey's location on the River Trent has been known as a center for the manufacture of medieval ceramics. While drifted sand layers obscure an accurate reading from geophysics, magnetometry shows significant potential for evidence of Roman or medieval structures. This supports the idea that Roman and medieval material, including that of the Viking Age, may be well preserved by these sand layers. Richards and Hadley, leading the current research project, were prompted to explore the area adjacent to and on top of a river bluff after examining the concentration of early medieval finds discovered by metal detectorists and field blocking. Test excavations were carried out in 2011, and finds were analyzed at the University of Sheffield. These excavations helped to clarify the area covered by the medieval settlement and documented the material culture of Torksey. Of greater relevance to this paper is the assemblage recorded by the Portable Antiquities Scheme in England from the area in and around the town. This slide here includes a 9th century Durham fragment, fragments of a 9th century Irish penannular brooch, a pierced Northumbrian styka, and a polyhedral weight of a similar type to those found in Beerfett and Cowpang. This includes multiple finds of clipped Durhams, fragments of Middle Eastern medieval coins, which are a characteristic sign of Viking activity, in addition to easily recognizable Thor's pendants not displayed here. Evidence of an international presence can be seen in more recent finds. During the last 18 months alone, the Portable Antiquities Scheme recorded fragments of hacksilver, gold ingots, pendants, and a plethora of Scandinavian gaming pieces. The overwhelming concentration of early medieval material emerging from the area on or near the river bluff corresponds closely with magnetometry surveys and strongly supports the identification of a winter campsite. To help support the conclusion that this is indeed a winter campsite and not just a settlement, one can compare the assemblage of finds from Julian Richards' work at the Anglo-Scandinavian farmstead known as Cottonby. Small finds from Cottonby show that a gradual change in cultural signifiers, such as in Richards and Haldenby's case study of copper alloy pins. Analysis of these pins shows a change in preference away from faceted pins and an increase towards disc-headed pins. This stylistic change is interpreted as a shift away from Anglican and towards Scandinavian preferences. This would be expected at a long-term settlement site, such as a farmstead. Compared to winter campsites, the variety of types of artifacts and styles is greater at a farm, whereas the assemblages from campsites are of a narrow variety and more distinct Scandinavian styles. Therefore, a typical winter campsite will have a wide variety of items, but stylistically may tend towards a narrower range than settlement sites. Another winter campsite, which has been positively identified but not clearly defined, is the winter campsite in and around Dublin, Ireland. This is a breakdown of coin assemblage from Torksey, compiled by Blackburn and Alfreton in 2007. And you can see of the coins analyzed, nearly all of them were 9th century or earlier. Viking activity in Ireland was markedly different from Britain. Scandinavian activity was limited to the coastline, with minor incursions inland along river routes. Howard B. Clark suggests that, in quote, Ireland in the 9th century was a land of kings, and a land of kings is almost by definition a land of armies, end quote. There is some debate regarding the location of a Viking winter camp in or near Dublin, but the main candidates are the Long Fort in Dublin, in what is now central Dublin, and a site near the Dublin suburbs of Islandbridge and Kilmainham. Dublin here is to the east, and the Kilmainham Islandbridge suburbs are further west along the Liffey. The Annals of Ulster refer to several different locations in different years, and these two different sites are both prime candidates to be winter campsite locations. Excavations, artifact types, and the geographic location of the Islandbridge Kilmainham site support this as a location of a winter camp site. You can see here the relative location of the two sites. The central Dublin site is thought to be just here along the River Poddle where it meets the Liffey, and the Kilmainham Islandbridge site is thought to be here on this peninsula of land which comes in between the River Carmack and the Liffey. The dappled area is thought to be the medieval floodplain of the Liffey, so you can see the site in Dublin puts that dangerously close to some of the area prone to flooding. The Kilmainham Islandbridge site has been excavated a number of times since 1836, mostly as artifact retrieval or recovery archaeology completed under the pressure of construction projects. Both sites contain cemeteries with Irish and Scandinavian burials, clearly distinguished by the orientation of the bodies and the absence or presence of grave goods. The Kilmainham Cemetery was associated with Kelmingen, an early monastic community. It contained 17 Scandinavian skeletons, perhaps 2 of which were female. 800 meters west of this cemetery is the Islandbridge site, which contained 13 males and perhaps 2 females. Though a careful inventory of the associated artifacts, and by tracking down 19th century excavation records, Elizabeth O'Brien has managed to make significant connections between far-flung evidence. This area, Kilmainham and Island Bridge, is further from the mouth of the Liffey compared to the Dublin Longport site, and fits the description of the Viking camp in Irish documentation. The Annals of Ulster refer to the establishment of a long fort on the Liffey in 841-842. Later references, such as the Annals of the Four Masters, indicate that the settlement is down the river, in Dublin, closer to the Pottle. The items recovered from the various excavations and inconsistent documentation at Kilmainham and Island Bridge can be filled in by analyzing the finds, which include weapons, tools for smithing, and trade currency among the male remains, and spindle whorls, needle cases, and jewelry accompanying the female remains. Elizabeth O'Brien suggests that, in quote, "It is likely that the burials at Kilmainham and Island Bridge represent a group of Vikings who were living in a defendable settlement located near the ford in that area in the 9th century," end quote. Clear archaeological evidence of the fortifications at Kilmainham and Island Bridge, if there were any, have not been discovered, but the Vikings here did face resistance from the Irish kingdoms, and defensive walls have been discovered at the Wood Quay site in Dublin. Clearly, the function of this settlement, to protect the longboats between writing seasons, was succeeding in 842 AD due to the many records regarding it. After this year, it is likely that the camp either moved to the site in Dublin at the convergence of the Liffey and the Pottle, or a second camp was established at this location. Those are the three sites. At this time, I'd like to invite up my co-author, Matthew, and he will discuss the database aspect of this project.
All right. Fun stuff. Talk about relational databases and geostatistical analysis. Okay. So, as you can see here, we don't have very many positively identified Viking winter camps at this time in the world. We need to increase the number of candidate sites in order to have reliable statistics. The biggest problem is that our sample size is very small and it's not representative of the population. In our case, our population would be all known archaeological sites. I think a lot of those can be re-explored and eventually reclassified as candidate Viking winter camp sites. As you can see here, finding them is very hard. It's nearly as hard as the Minnesota Vikings winning, who also harbor inside a building all winter long and wait for better days. Okay. So we do have some great sites. The ones she discussed, Danielle discussed 3 of them. We have a few more. These are the Disney princesses of Viking winter camps. They're great. You should hear them sing. They fit every variable that we would need to create a model. More than enough information. We need more like it. We know they're out there. We need to identify them. So I'll be going over this slide a few times briefly as we go through these steps. But the strategy is fairly simple. We create a template database using a relational database of the variables that we have determined and the metadata on these variables. We'll gather the data of the known archaeological sites, which would be the actual winter camps that have been identified, as well as other archaeological sites that are currently not determined to be Viking winter camps, maybe have a relation to the Viking Age, maybe not. Maybe they were excavated or surveyed 150, 200 years ago, and it would be worth taking another look now that we have new technology. We will insert these sites into the spatial database alongside the sites that are not currently Viking winter camps, fill in the gaps using all our resources available, the internet. Some of these gaps in the studies could be filled in with an email, a phone call, raster analysis, watershed analysis, things that were not available maybe even 5 years ago, and certainly not 50 to 100 years ago. We'll then use the relational database with several weighted models, the key is several weighted models, to expand our sample size and identify likely candidate sites. We would prefer to get somewhere between 30 and 100, basically what we could call mathematically a Viking winter camp. Just somewhere under a dozen probably wouldn't cut it to have a high degree of accuracy. That's kind of where the first part of the study would maybe have results. And after that we would go into the more complex geostatistical portion, which would be to gather the imagery and geologic data of the areas of interest that we'd like to identify, brand new sites that aren't even archaeology sites, such as coastal France. Interpolate these potential sites. We'll talk about interpolation really quickly. From raster imagery, vector imagery, things that weren't available prior. And then we'll find the Vikings. It's easy, right? Okay. So in essence, like I said, we're reverse engineering a Viking winter camp mathematically. We're giving weights to chosen variables. There's lots of variables. I'm going to show you some sample database tables that we've been putting together. We haven't drilled down exactly, as this is a hypothetical study of the variables we're going to use. There are many. And we haven't assigned the exact weights, but of course we'll have multiple models, so we'll have multiple weights. Some of the models will be geospatial only. Some of them will take into account heavily attributes such as the composition of what they found, the soil, things like that, that wouldn't necessarily lend to a continuous spatial model. And we'll compare those models and see where we get. I don't have a Viking here to tell me what each variable should be weighted as, so that's another reason that we're going to need to make several models. Okay, so just really quick to go over the relational database that we're going to use. A few reasons why we're going to stick with this. Structured query language, really easy to use, easy to learn. That's what I do as a profession. And there's numerous GIS applications that already exist and are built on relational database platforms to crunch large amounts of spatial data, and not necessarily proprietary. There are also open source applications available that have very similar functionality, in addition to what Esri and GE, some other major players in the GIS field, create. So that I've always liked that picture. Just kind of shows you, it looks like a headache, but a relational database can be a beautiful thing. You can, of course, create the same picture with 4 tables with a whole bunch of columns. It really depends on what you're doing. So the design and organization of the relational database, especially when you have spatial columns and indexes, becomes paramount. Our design does not look like that. But we can have very complex relationships when we need to. Okay. So to go over the design really quick, I'll talk about the 3 main tables. There's probably going to be hundreds of auxiliary tables and views. But to go over it really quick, so the first one is the user-friendly table. This is the site data table. And what this is it has everything. It has every possible column that we might want to record, anything that we think we can find data on all the existing archaeological sites that we archive into our database. A lot of this stuff is, like I said, we need to fill in the gaps. So we need to make phone calls, emails, go through imagery, go through surveys, whatever it takes, and fill in the gaps. And there might be some variables that we really want, and we won't be able to gather enough information out. And that's something that we're ready for. But we're thinking that we're going to get anywhere from 30 to 50 variables that we will be able to use in these sites with a high degree of confidence in that metadata. Preferably, the majority of these columns will eventually be whittled down to Boolean in nature. So basically, ones and zeros, trues and false. Really easy to say, yes, this is an effect in this site. No, this is not. We found weapons. We did it. We'll go over that in a second. But to simplify it is very important here, as we will already be using quite a bit of math to weight the variables, especially if we go with over 24 variables to create our models. So that, yes, this is the friendly table. This is what you would use in ArcGIS or Quantum GIS or whatever you use. You could even export this out into an Excel table, look at it on Google Maps. Something that you would be able to publish and share with people very easily. Second part is the part you'd only like if you like databases. And this one's going to be basically all integers, and this is going to use what we call computed expression columns. So basically what that is we have a column that is the variable, and let's say the variable here would be elevation. That's simple. That's simple because it's a bad example. But let's say, like I said earlier, found weapons. So that'd be a 1 or a 0. That would be a yes or a no. We take that and we multiply it by its weight. Let's say that we decided that the importance of finding weapons in the Viking winter camp would be 0.025. We're trying to reach up to a large match percentage number. As that data is entered, either automatically as we script it or manually if we fill it in, depending on what stage we're at, the third column is automatically going to compute that and then return that into different feedback for us. The computational number is very important in that it can change as we add more data to the model and to the sites that we explore. So as I stated, each model is a combination of different weights. And logically, we'd like at least 3 to 5 models, with a few of those dedicated to spatial, the other ones more general. But of course, the database is capable of doing many more than that, even open source databases. In this example, I was using SQL Server Express. You can also use PostgreSQL. There's Oracle Express. There are open source license-free databases that can be used to accomplish this. You don't need to be a millionaire to run this study, or get permission from the dean. Okay, so, and the third part, like I said, is just a view of the computed columns, which is our match number. What that really comes down to is choosing a certain threshold. So at the end of the formula, it's all computed. It's basically just an equation or a simple function, and we have a candidacy number, and we decide, okay, 85 or 0.85. That's the number. We're going to look at those. Mathematically, we have now decided these are Viking winter camps. Maybe they're not. Maybe they are something that is coincident to the Viking winter camp. Another study from the 1500s, another type of settlement. That's okay. We're all right with that. Maybe some of them will be. They'll be reclassified. So like I said, a successful model is not necessarily a model that produces more matches or overall ratio. A successful model is one that would be used for the exploration or reclassification of an existing site into a Viking winter camp, as well as to increase our sample size. Okay, so I'm not going to bore you with too much SQL, but this would just be a simple definition of a table, and all I really want to show you here is that this would be about a third of the columns in the user-friendly table, and as you can see, different data types. I'm not going to go into the constraints and triggers that would keep everything in place as we enter the data, but there's going to be a lot of information here, so it's going to be really important that it's organized well and related well to the other tables. Quick interface, SQL Server Manager Studio, if anybody's ever used it. We'll be using multiple relational databases for this study. This one is very easy just to show. As you can see, you just have very simple table structure, column structure, column descriptors. There's quite a bit you can do there within this. Most relational databases have a user interface that you can use. The free ones are actually the best ones, even for the expensive databases. Here's an example of the sites value table, which is the one that's going to have all the computations. And as you can see really quick down there at the bottom, I use tools found as an example. So you have a tools found weight column, which say 0.025, something like that, whatever we determine the importance compared to the other variables. And you have the tools found count. And as you can see, that'll be a computed function that will be updated dynamically as we input that data or as we regenerate the tables with new weights, because new weights equals new model. As simple as that. Okay, so that's where we are at number 5. And at that point, I guess you can say that the study is half over in the sense that we have increased our sample size. We can run statistics with a higher level of confidence, and we may have identified, reclassified Viking winter camps, or at least opened up for exploration. So now we have a site, we have a match score, we have a winter camp candidate. So we take those, first thing we do is very simple. We plot them, we look at it. That's how the human eye typically makes connections. You look at it, you throw it on a map. That's easy, right? Some of this stuff might stand out. You don't need statistics. You might see these 95 new points, and you say, okay, well this makes a lot of sense. There might be a site here. This is definitely going to be a site. There's things that we can look at that aren't necessarily scientific and more logical, and as you are all trained in the field of Viking archaeology, it might stand out to you pretty quickly. And then it gets more complex, and then we talk about Kriging. So, really quick definition. Kriging is an interpolation method. It's basically a prediction of an unknown site. I don't want to go too much into semi-variograms and levels of confidence and things like that. But the point here is that we are going to use the sample sites as interpolation to predict brand new Viking winter camp sites. So basically, an area that would be suitable. In this situation, we would use a model that was almost entirely determined by spatial attributes that we collect on the sites. And there's a quick equation there. I'm not going to go over the variables in the Kriging equation. I believe that's simple Kriging anyway, won't be using that. And there's a quick picture. And really all this is just a kind of a weighted moving average. But the point here is we're finding brand new stuff. These are not even archaeology sites. This is where we think the Viking sites could be. Okay, like I said, we're going to need to gather a bunch of data. A lot of this is already available. Imagery, hydrology data. Some of it needs to be vectorized. Some of it is ready to roll. Some of the tests we're going to be running will need rasters anyway. Finally, just to finish up here, we're going to have multiple models. Not all the variables can be used geostatistically. That's very important. And just as an example, this campus can be used. You know, we can't say there's weapons here, but we can say, we can assume, but we can say that it has all these other spatial qualities. Either way, there's not a winter camp here in Kalamazoo. Okay, and that takes us really to the end. And any technical questions about the geostatistics we can go over.
Okay.
So let's finish up.
While we hope to grow our sample size in order to move closer to a statistical model of a winter campsite, we have observed a few similarities within our known sites. The only main difference was in the relative distance to open water, with the English sites being further inland and not located on a tidal river. All the sites use natural defenses when present, including elevated land, marsh, or floodplains. Temporary defenses such as ditches and perhaps banks were constructed as necessary, but are not known to be present at all sites currently. A location at or near the convergence of multiple waterways appears to hold high importance, and these sites are associated with an established religious community or worship center, so they would therefore be associated with the native population. Material culture, whether discovered by field survey or excavation, will be focused in style, but varied in form and function. Artifacts will likely include evidence for manufacturing, metalwork, gaming, or trade. And if excavated, burials with grave goods will likely be present, with a high percentage of adult males and a few females. As this project goes forward, we hope to continue to expand our database and identify potential candidate sites. The strongest candidates will be added to the sample pool, thus allowing us to interpolate the most likely locations of Viking winter campsites in conjunction with the analysis of historic texts. Thank you.